I will use that to choose a problem on Codeforces. It will be of difficulty, I guess, around 2900, so it will be fairly hard. Did you start ads on Erichta 2? No. On Erichta 2? Are there any? On Erichta 2, I'm not affiliated at all with YouTube, so you shouldn't see any ads. Seems strange what you're talking about. Okay, so there is this. My Discord server, by the way, joined the Discord. I think I can type git good, and it gave me a problem. I just need to make sure that I didn't participate in that contest. Announcement. No. What I'm trying to get is link to Division 1 version of this contest. This is I hope here to actually click announcements. In particular, I know this prefix of a problem, ehab and stuff, but maybe just this author always uses that. Well, I didn't recognize this, so I think this will be a new problem for me. If that's the case, then let's try it. I'm not taking suggestions now. I will solve this problem because, well, Discord bot chose it. So we'll see how it goes. Also, solving a stream starting now. I think Dangel is Dangel, am I saying that right? Is the developer of this bot. Yeah, Dangel. All right. So let's do that. You can skip git good problems only after 3 hours. I'm aware. So let's hope that this is a good problem. Let's give it a read. Oh, and then I will add stream to Codeforces. And strings and queries. Longest common prefix. I think that if we build something like try out of this, we will know common prefixes. Or we can even do that with a brute force. This might not be a string problem, but I'm not sure. Hi Palindrome, hi Rainier. So that Codeforces would see the string. All right. We're given some strings. For every 2 consecutive strings, I can compute their longest common prefix just with brute force, because in total it will be linear. For those 2, the common prefix will be 0. For those 2, it's 1, 2 characters, dr, dr. For those 2, it's 0. Again, wait a second. It's not sorted? But do I mind? Oh, I changed strings. But after changing a string, then I can recompute longest common prefixes, because the complexity of that will be related to the length of this new string. So that's fine. And then I think that we will just need this sequence of longest common prefixes between neighbors. And then what? Also, constraints are so low and time limit is so big that we might be able to use square root decomposition or something. We might have square root in complexity. LCP for range doesn't matter, but I will know LCP for every two neighbors. And then LCP of a range is just minimum of this range. The stream today will not be easy, because this problem is, fairly hard. No matter what strings you have, string 1, string 2, string 3, string 4, string 5, they don't need to be sorted. If you know that the common part between first and first string and second string is here of, let's say, length 3, then the common part between those two strings is of length 2. And here maybe common part is of length 7. And so on. Then if you want to know longest common prefix of everything in a range, you just take, it's enough to write this once. This in any range, you just need to take minimum out of those values. So what we maximize is, in a range from A to B, we need to maximize the length of chosen subrange multiplied by minimum out of some values in between. Let's call it diff of L plus 1, and diff of R minus 1 will refer to it will refer to difference between R minus 1 and R. This is score of a range from L to R, where diff of L is LCP of string L versus string L plus 1. We can compute LCP with tries, but here you can just do it with brute force. And please don't ask me too many unrelated questions, because then I will not have time to solve the problem. We will maintain the sequence of those differences, I mean not differences, LCPs between neighbors. Maybe we should then call it LCP. This is LCP of I is LCP between string of I and string of I plus 1. We have updates on this sequence, and we have queries about maximum of this as a subrange of AB. How do we approach that? There is a sequence and there is a query in this range. Choose the best subrange. Subrange might be this, where it's minimum multiplied by something. If we didn't expand by this element and this one, it means that those two are smaller than everything here inside. Maybe a minimum here inside is 5, this element is 2, this element is 4. Then this is possible. This almost works as a whistle. Good luck today. Thank you. Croatian Olympiad competition, open competition, not this year. I mean, Timothy, if lengths here were bigger than 10 to 5th, then the input would be too big. We don't need to think about the speed of algorithm if it's not slower than reading the input. Maybe for every element I need to know the next greater element and the previous greater element. Or like next smaller and previous smaller. But with one update a lot can change. What's more? Okay, the sum of values LCP is O of n. Because every LCP comes from some string from the input. Maybe this is a strange way to put it, actually. So the sum is O of n, but this is limited by n times something, or like 10 to 5th. This n refers to the sum of lengths of strings, which means that in particular there are square root of n distinct lengths. Maybe in this subrange I should iterate over what should be the minimum, and if I focus on this minimum I will get something. Can you add today? I mean, I can add today. You know, the title says everything, I think. There is nothing other than just the title. It's quite hard Codeforces problem solving, that's it. Hi, HBR. Okay. Low constraints and big time limit. Let's go for this square root idea. Observation. Most of square root distinct lengths or values of LCP. I'm not going full screen with drawings because I want new people when they join to still see the statement, so you would be able to read. Value comma range where it is minimum, but then a single update can mess up everything in that data structure. If we lose some small value or if we get a new small value, there can be linear number of changes in the structure. Or maybe square root. For every position, should I know where is the next occurrence of this length or that length? If I want to take a lot of elements, then for sure some of them will be small, because I cannot afford so many big elements. So if my range length is at least square root, then there will be elements smaller than square root inside. Then I can iterate over minimum that I try to achieve. And if the length is smaller than square root, then what? I'll need to think. Split around the minima. How? remember that there are many queries. The only way when the whole range is not short is that a lot of values will be like 1, 2, 3, 4. Divide and conquer. I cannot apply that for every query separately. Divide and conquer sounds like n log n. Compressed array consists of small values, but what is compressed array? Sec tree on those values. I mean, there are quadratic number of values for pairs LR. Remember that we aren't asked about score of range AB. Inside AB, we need to choose best subrange. Max area of rectangle in a histogram? Oh, good point. Yes, this is exactly Queen, very good observation. This is just histogram area. The thing is that histogram area can be solved linearly, but it will not help us here because we have queries about some ranges. And maybe this will allow us to think easier about everything. Maybe it will allow us to make drawings, but that's it. We need to use the fact that there is a small number of distinct values. Can I explain the problem? Well, just read the statement if you have just joined the stream. The plan for this stream is to solve these, say, medium-hard Codeforces problems. I will not take suggestions from you today because I'm using Discord bot that suggests problems. You can use it too. Join my Discord server. Why am I so tired? I need to grab some water, sorry. Coffee is awful. Coffee bad, energy drinks bad, because they are unhealthy. I think that cold water is enough. Tea? Does tea stop making you asleep? I mean, does it make you awake? I don't think so. But cold water? Come on, it will work. If we have a query about this range, I can see where some minimum is. Minimum will most likely be 1, and maybe 1 is in more than one place. I think that I need more slots. Okay, there is a query about this. And sure, 1 is here, there. What do I do with that? Either if I take if I take 1, then I will just take everything. If not, I can go recursively to those subranges without ones. But 1 can be even on every second position, and then I will go to linearly many subranges. This is not a good solution. Though maybe what I should do is I maybe should pre-compute what's the score between two consecutive ones. And then what will be left is to solve it here and to solve it there. Then if I focus on that part, I assume that something like this I already know from kind of pre-processing. Maybe I will have a segment tree, and on every position it will know what happens when I continue to the next number of the same type. And I will know what the best score I can get by taking subrange of this yellow range. If I focus on this, maybe those two parts should have different colors. So yellow stuff I will grab from some kind of segment tree. Then blue. Blue I need to take care of. I treat those as just smaller queries. Let's look at this. We know that and every element here is at least 2. So we have this subrange with values 2+. And I hope that I will go recursively down only, or maybe not recursively. I will go down to a smaller range only at most square root times, because this is how many distinct values we have. What do we do here? We are looking for the minima. Let's say that the minimum is 2. It's here, 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 there. We have something about those ranges between them. And then, with a different color, we will have those two special cases. But this left one, I would say that I can handle that by saying that from 1, no, that's bad. Maybe from 2, I go to the left to the next number equal to 2 or smaller. But that will be a lot of updates. So no. It seems that every time I go deeper down, I get 2 new ranges, and this is bad. If we go like that, then the complexity will limit just by 2 at power square root of n or something like that, and this is not good. This is huge value. Of course, it will not get that big because the total number of ranges is just n square, while this is exponential. But well, I would need to say that we only go down to one of those 2 ranges, not to both. But this green guy, this is something between consecutive 2 and 1. Maybe between them I can also pre-process in some way, still with updates, and then I will be left only with the right green. So when I have query about this, I ask a segment tree about those internal ranges between consecutive ones. Then what remains is to handle this blue prefix and suffix. They are internally also split with some yellow subranges. And we have here this guy and this one, this guy and this one, and the green internal ranges I hope that I can also handle with preprocessing, because each of those, this one and this one, they are between the consecutive 1 and 2. And this one is between consecutive 2 and 1, or the other way around. If that's the case, then here I should focus on those still prefix and suffix, green, this and that. While the thing here just before it was 2, and I'm looking for a 3 here, but what if I don't find it? Okay. It's not always between consecutive 2 and 1, because maybe there is no 2 here inside, and then I need to jump to 3. So it seems to be between any value and the next value smaller than or equal to me. But still, maybe an update will modify only square root values. What is 1, 2, 3? Values. The value of LCP. What, chat? You're saying that histogram will work better? Maybe. I will continue this. The value for me is LCP between two ages and strings. Still continuing this idea, maybe later I will consider histogram 2 and I will implement the easier version out of 2 options. Let's think what happens when there is an update. There is a sequence, and let's say there was value here 3, and now it's changed to a new value 7. What happens? If I know the best solution between every 2 consecutive equal values, like there was 2 here and there was 2 there, everything here should be greater than that, then I don't need to modify anything. What if there was 4 here and 4 there? Then now that there is 7 here, maybe this is a valid interval between 2 4s, and the minimum is new. So when I change 3 to 7, I need to find the previous 4, the next 4, and I should look at this interval and ask about minimum. And this will be logarithmic already. Maybe square root times logarithm is a good complexity to have, but it's for sure ugly. And then if we realize that in this range there are also subranges, I don't need to take the whole thing. So I'm not sure how do I know the best value from here to there. Okay, I'm switching to the histogram idea. But again, I'm not sure about this. In this problem we have a histogram with some heights. And there is a query about some subrange, let's say this one, and we need to find the biggest area of a rectangle. Maybe it will be like that, maybe like this, multiple possibilities. 100,000 queries, 100,000 updates. Update is change the height of some column to a new value, and additionally the sum of values we get is linear, 100,000. So there won't be a lot of high or tall columns. Or there is another observation we can make: there will be at most square root distinct values. And how do I answer this query? In this range I can consider what? Every minimum it seems to give me the same idea as before. There can be a lot of occurrences of this minimum. Can I put a problem here? No, I'm solving another problem. You should ask in some kind of forum, or Discord server is fine too. Thinking about it as a histogram makes me again think about this example. If you have some x, you want to replace each element in range with 1 if greater or equal x. Yes, it's one way to think about it. Okay, let's focus about one single minimum and let's try to handle it in linear time or constant per query. Let's think about some fixed minimum equal to 4. Then we have a sequence. Some values are smaller than this minimum, so they are bad. I shouldn't even consider them. Other values are not smaller than minimum. And we care about the biggest range inside the query, like from here to there. I should then consider starting from the start, where is the next such possibility, starting from the end, same thing, and then some query inside. Let's say that the range is from here to there. So we will consider this, that, and then we have some sub-ranges. Maybe again it's good to look at that. But then I need to know that. What's the best here between those? I just need to know this length, not really the score. For a query, I will iterate over for every query, for every value, let's say x, consider x to be the minimum. The query is about range A to B. Check prefix of AB. This means how long from A we can go to the right and still not go below x. Check suffix of AB and ask about longest good subrange of AB. What is longest good subrange? For every position, we can know the length until, and that's an issue. I would be happy to say length until the next forbidden element. But they are not necessarily equal. When I forbid something new, but it's not that bad. If I put everywhere some value, like here 3, because just after this red X there are 3 empty slots. In this red X I would put information about however many there are here on the right, let's say 7. There's a query about interval AB. I handle the prefix, the suffix. I'll now disregard this X that tries to go to suffix and continue. And I ask a segment tree here about the maximum yellow value just above the red X. Then, when there is an update, some cell turns red, turns forbidden. I will update the value here and in the previous X. I will do that separately for each of square distinct values. In each of them I need to use a segment tree So it is O of n square root of n times log. But I think with those constraints it should be fine. What if there are linear number of set ranges? But I ask a segment tree about the biggest value here inside, so that's not a problem. And if x disappears, then also it's about updating the value here and there. By default, every value will be just 0. If there is no x somewhere, it is 0. And in this range, I'm asking about maximum. Here, maximum is 3. Okay, this is a working solution in n square root of n times log. This is logarithmic complexity, and I do it for each of for every possible value, and there are square distinct values. Am I going for git good monster in the server? I think it would take a lot of time, so I'm not sure. Those hard problems take a lot of time. If you are of rating 1000 and you're solving problem on your level, it shouldn't take you 2 hours. Once you're at some level, you should solve problems that take you 2 hours. Don't even do competitive programming. Should I watch you? I think not today. Today is not educational stream for beginners. This is hard stuff. Square distinct values, because the sum of them is at most n. So there cannot be more than square distinct values. There are divisions though, I'm aware, but still in my division there will be people with lower rating. Is this complexity good enough? In some old problems on the right there is info about doubling the running time. Here there is no such info, so I think we're good. This is, let's call it query of AB, the function, and update of position I to value X. Actually, every update triggers 2 updates in a segment tree. That's not nice. Let's say new value. Again, for every X, X here denoted a candidate for a minimum, and here also X is candidate for a minimum. Now, if new value is smaller than X, then it's I is forbidden. So that forbidden means red position, like red X, and else I is not forbidden. Like that. If I want to care about the memory, I can, for every distinct value in the input, I can go through the whole input offline, solve it, because I will get some answers out of it, and then I'll go again. This way, always I will only need one segment tree. What else? Forbidden positions I will, I guess, keep in a set to quickly access the next after prefix and the previous after. I mean, for a range from A to B, I need to quickly know what is the first red X and the last red X inside the interval, which can be done with a segment tree, and maybe it would be a bit faster, but set is more convenient. What I'm afraid about is that this will be n squared n times log with a big constant factor. Because I have multiple parts, each giving me logarithm. There is a set, there is a segment tree. I need logarithm both for a query and for an update. So it's not that it will be log, but only in some queries. Find first and last forbidden in AB. Forbidden means smaller than x. Consider from A to first minus 1 and from L plus 1 to B, where F and L refer to those first and last forbidden. Plus 1 to be the answer. And here we ask about best in range from F to L minus 1. F is this first red X inside the interval, and L, the last, is this guy. This naming is maybe a bit poor. Like that. When Gauss, I don't know. I am now just thinking about a way to avoid the logarithm if possible, because it might turn out that this is a bit too slow. But I don't see a way to how to do it without a segment tree or a set. How just a single tree? I will do it offline for every distinct value x separately. First, I will solve the whole problem just assuming that minimum should be 1. Then I will consider the minimum to be 2, and so on. But if string lengths are up to 10 to 5th, then LCP, the sum of LCP, will it be the same as the sum of string lengths? I guess so. Maybe twice bigger. If I have a long string here, a long one there, and then this one, and then I change the middle one, then I have here extra 100 characters, and I change the value between them maybe from 90 to 100, and I change the value between them from maybe 95 to 103. Maybe here the value, the length so far was 1. Then I have big changes, but then previously it was some wasted amount. I think I'm not sure about this. Now I'm wondering if the sum of LCPs that I will deal with is 100,000 or 200,000. If 200,000, then I think my solution is too slow. It would take me years to get to this level for solving such hard problems. It also took me years to get to this level. Let's code this. How is this called? LCP, I guess. Okay. Well, reading the input might be useful, but I will just put the statement on the side. You will not see it. There's N and Q. Then there are N strings. Then there are queries. First there goes type. And there are two types. One is the query. And it satisfies this thing, this inequality. This is update. This updates like that. String of position becomes y. But this goes from 1 to n. I guess after reading I will subtract by 1, same here, and now I have values from 0 to n minus 1. Uh, 100,000 divided by 2? I don't think so. I mean, I think I see a case where it would be 100,000. In particular, if you have 100,000 strings of length 1 or length 100, they will be all the same. Sum of LCPs will be exactly equal to the sum of string lengths, minus the length of the last string. 100,000 minus 1 I can believe. Yeah, I hope so. But then there are updates. And I'm worried that an update can change two LCPs, like the one with neighbor, previous neighbor and next neighbor. But I think it will be fine. Just as long as here we do something only if there is a change. LCP of I is LCP of si plus 1. Always like that. This is why the size is smaller by 1. Just with brute force I will find lowest common prefix. Done. Brackets are wrong. Oh, the comma instead of semicolon. We don't even need to try, because it's not that I will multiple times run this function for the same string. I mean, always I run it only once for the input, and then when there is update I try this string with previous one and with the next one, but the complexity is limited by shorter of the two, so it's fine. The complexity of this in total doesn't exceed complexity of just reading the input, so that never goes wrong. When there is an update, I should also remember that in some way. If this, then we have comparison with a neighbor. Let's say something like that for now, but actually I want to remember everything. I is a very bad name here. Let's call it ID. It will be query ID. I was a bad name because I by mistake used it here instead of position. In this case, if I'm not the last element, then I consider with the next guy. But I want to remember all those changes, and for every different x, I want to go through stuff. Values. This will remember all the different values I ever get. Which I can as well just insert here. I claim that the value size will not exceed square root of 100,000 times a constant. I will not store the exact, oh yeah, I will store queries too, but I will not store strings from updates. Here, instead of just overwriting, I will remember what's the change. But here I will go through now all the queries. What do I do? What do I do? Guess query of ID becomes query of AB. Okay, query will be just query. -1 denotes that there is no query at this point. There is just an update, and here updates of this time, pushback a pair position -1 LCP of position -1. Like that, and I will not overwrite this, because what's the point? But what I will do is I will remember this initial LCP. And always for new x, I start with this. Okay. Value, of course I meant values, plural, and I need to now go through all the queries and answer them, assuming that x is candidate for minimum. And now time to follow this. I will need to use a segment tree, but temporarily I will just do it with a brute force, just hoping it will work for samples. Then I will add the segment tree as well. For every query. Here answering query, else updates. I need to do something here and there, and this is respectively query and update. I think we should first handle update because, I don't know, maybe query. It will then show us what we need to maintain, so what we need to modify in an update. Find first and last forbidden in AB. Using this. Oh, from LCP I only care about like which values are smaller than x, because those are bad. This is bad. Okay. Now, well, I want the longest interval without bad elements. I can do that with a brute force. Let's do it for now with a brute force. Just using isBad, but we will need to modify it quite a lot. This is a way to find the, I can as well write that down, longest non-bad interval within AB. Whenever I see something bad, I reset the counter. And here, I need to do this, but I should do that first. If this element was bad, or if this, whoever this element is bad is different than whoever new value is bad, then isBad becomes the negation of itself. And this, yeah. If we need to change, then change. Compile. I will copy the sample test. 14, 14, 13, 30, 12, 7. Yay. What happened? Okay, run on in. line 33. What I run is called GDB. Compare yourself with the previous element. Still this? Why? Oh, LCP of -1. Come on. Now line 72, that's some progress. There is a mistake here. Oh yeah, is bet can be only of size at most and -1. Does it mean that... Oh, wait. You shouldn't here print best. Best is the longest interval, and actually I should find it from a to b -1. Can a and b be equal? They can be equal. What does it mean? It's not minimum of something. Well, I need answer array of size long. No, because it's area, so it's limited by the input. Answer and by default filled with -1s. Then when there is a query, I can take a single element. I didn't think about it so far. Go through the whole range. Answer of I maximize with just length of a single string. And from this moment onward, I can just think about differences. What happens when I find this best? X was the minimum, and best is length of interval with values at least this. So I need the product of those as well, area of rectangle. -1 just means that there is an update rather than a query. (86) is but of j. Yeah, and now I think b that I should remember is b -1. Right, because only in this range. It's not that from b I need to look at neighbor to b +1. Well, let's leave it here as AB, but in brute force and then in the better solution too, I need to be aware that, well, from B I cannot go to the next guy. So, right exclusive it's called. Oh, okay, GDB. (93). What do you want? Answer of ID doesn't exist. Should be of size Q. Is this O of n problem? No, it is not. Something's certainly wrong. I got too many values. it seems that the number of values I got is equal to the number of queries, so it doesn't understand that there are updates. Answer is filled with -1s. Later, answer of ID. Maximize with that. That's something. I'm guessing that this will be just length of a single string. I can't believe that this is 13. Right. What about we, for starters, print LCP after every update? If there is an update, and before everything. What do you want? Oh, it warns me about indentation, but I was aware. LCP doesn't change at all, which is, I guess, suspicious, but even so, this is bad. This guy is changed to Mahmoud, then the common part is still 7, this common part is still 0. This does nothing. This should decrease it from 7 to something smaller. I think that this should not be 7. Something is wrong. A lot of things are wrong. Oh yeah, I'm not modifying LCP. So let's do modify LCP in order to now see some changes in this LCP array. There are changes indeed, but some wrong ones too. Changing this to Mahmoud should not make LCP between those two guys bigger. So there is an issue. Before everything, then session 1. Oh, position 3 we changed, not position 2. This one. Okay, then this is correct. This is correct update. My bad. Okay, then for now let's remove this and focus on answers. Yeah, it's not the best. I think that the number of things we take should be increased by 1. If I see one difference in a row, it is if there are 3 positions in a row, they only have 2 differences between them. So best equal to 2 means this situation, so the actual number of elements taken, the number of strings taken, is bigger by 1. And is that it? Cool. We solved the problem in quadratic complexity. That's a good start. Oh, I'm not actually sure if it's quadratic, but for sure it's slow. Right. I would start by thinking how to speed up the query. Also, let's copy this to LCP brute force CPP. but I can store in a set. Initially, I will put -1 and n, I guess, for convenience when asking about the next bad, previous bad. Maybe let's rename longest. Longest is more meaningful than best. By the way, I'm surprised why so many people are watching today. This is a quite hard problem, right? What is the difficulty? Oh, the difficulty is not displayed, but it's for sure at least 2500, maybe close to 4000. And then usually my number of viewers halves or so. I would expect fewer than 100 on Twitch for sure. 2900, okay. And also, I don't know if I have the intended solution. There is a possibility that I will just get time limit exceeded and will not be able to make it fast enough. All right, find first and last. This is first at B or later, and I want first strictly before B. That's function previous using iterators. Then longest is maximum out of 0. First minus a. If first is just 1 to the right of a, it will give me 1. Cool. B minus last. Again, that's not so. I'm not that sure about it. If last is just to the right of b, then there are 0 elements. That should be b minus 1, because b is exclusive. Okay. And then I claim that it's enough to go from first plus 1 smaller than last. This is not correct. Actually, this might give me too big of an answer. I should kind of minimize it with range from A to B. But if I replace this back with A and B, would it work? Oh, I don't update the set. I do not update the set. And I have here too big of an answer because I don't minimize with the range here. And now set gets updated. Yep, it works. And then instead of this for loop, I want to use a segment tree. And segment tree should be built on values. For this position, give me the distance to the next forbidden position, maybe -1. Right. Let's call it dist. By default, everything is 0. Should I include the very end? No, it doesn't matter. Previous is n or whatever. But go backwards. If something is bad, distance of I is previous minus I. This will be just the difference between two consecutive to next forbidden position or bad position. Bad and forbidden is the same. But then, if there are 2 units away, I should take this minus 1. Do I want here minus 1? I guess so. So this is actually distance minus 1, so the number of available spots in between. Right, then from first to last, we have this. And now we can see that this will be easily replaced with segment 3 because this is just RMQ, range minimum query. But I still need to update this in this case. If I insert a new position, well, then stuff happens. Let's get the iterator of this insert. Right, it works like this. Okay, now iterator points to this position. And I need to say distance of at this position is equal to next iterator minus myself minus 1 and distance of the previous guy, so I need prev of it, let's call it left, this is the previous guy, for left, unless this is minus 1. This is position minus left minus 1. And I messed up something. There's prev, but there is no next. Or maybe this second is a Boolean value, right? Yeah. Insert returns a pair, iterator, and Boolean value whether you indeed inserted or not. Okay, when we erase, distance from you becomes 0 because you're not bad anymore. But still, I don't know what erase returns, but well, this iterator doesn't work anymore. What do I need here? For my left neighbor, now his distance to the next is distance to my right neighbor. Then in any order do those two operations. Okay, as expected. '88. That is bad of I. Yeah, of course. Not really. But only one value is mismatched, the first one. I got some big value and I shouldn't. What can I do? After every update, I can say, I can print is bad. This will print 0 or 1. And for starters, let's just print the set to see if the set is properly updated. But I think it should be. Here it doesn't contain any elements other than the special -1 and 5. There is 0, 1, 2, 3. That's right. That's right. That's right. Okay, and now we also add the distances. By default, all are 0. This shouldn't be 1, should it? This fake value should be n rather than n+1, which should not matter. I think that I will never access that element anyway. But maybe... Why is it 5? Oh, because n is 5. This should be n-1. This is the fake element. Zero, 1, 2, 3. Why 1? Don't I do the difference -1? If now this position is bad, then insert this guy, and my distance is next value, which is 4, -3, -1. That should be 0. Let's see. Hack didn't happen here. Why? Because it is a new distinct value, and previous I assigned like that. And the answer changed. That's suspicious. But I claim that if I go to last -1, then this never happens. I'm surprised that the answer changed. If I put here even n+5, the answer should not change. But it did. So there is some moment when I use distance at some guy that then points to the very last element. So this is huge just for the last bad element. But I go smaller than last. When do I use distance of that? Line 100 smaller than here? But I do j smaller than last. Yeah, like if I did this, then I agree that it could be an issue. I claim that this is b or something bigger than b, but then previous of that is strictly smaller than b. I mean, well, that doesn't matter much, but this is some position within the bounds. Can it be n minus 1? B can be n minus 1. So this can be n minus 2. But still, we go before that element. I don't understand. Previous of upper bound? Because I want to get the first one strictly smaller than B. This is why I don't use upper bound. Lower bound allows taking B, and then I drop minus 1. Just for a second, I will consider upper bound here, but I don't think that's right. Yeah, it only made things worse. Okay, this is a situation that I don't want. So let's see. Well, this distance is completely messed up, so I don't update distance properly. That's it. This should not be 8, obviously. This should be distance to the next guy, so 2 minus 1, so this value should be 1. But I don't update. Let's see. If I remove something, previous not changed. Oh, of course. Yeah, thank you. Previous is equal I. That's better. Thank you, Itarin. I think that I want to claim assert false for now. Then doesn't matter if I print stuff. All right. And now what's left is to replace this thing. Well, I will just remove this. We need to replace this with a segment tree query. And whenever we change the distance somewhere there, we need to update on the segment tree. Easy stuff. And I want to build a segment tree every time. I don't want to take new memory that often. Like even this I don't like. Well, okay, this is fine. Still, the bottleneck will be logarithm from moving through a segment tree. Building doesn't matter. So let's build it separately here every time. I compute distances, find bad positions, compute distances, build a segment tree. I'm not explaining this because it's just, you know, a segment tree. I always do it iteratively, and sometimes you cannot do that. With very complicated segment trees, you need to do it recursively, but the advantage of iterative version is that when you can use it, which is easy problems, it is faster, so better than the recursive version. Alright, this is a segment tree query. Maybe should have extracted that to a function, would be nicer. But too late now. And there are updates. Update is here, there. Okay, update must be a function. Do I care about changing distance? I don't think so. Update is of course logarithmic and query is logarithmic as well. Tree update now. Everything. This. Yep, that's everything. What is shadowed X? Out of bounds. Where do I create a tree? 2 times base, not 2 times n. Whenever you get out of bounds, your first thought should be maybe my array is too small. And is this good? Yes, it is. First try. Come on. I can obviously get wrong answer. I can get runtime error if I use wrong indices. I can get time limit exceeded if square root times logarithm is a bit too much. Am I good in Java? Not good, but I can code in Java. Wrong answer. Oh, yeah. Gupta already found the mistake about the size of a tree. Wrong answer. Now, I many times stress tested during streams, so it will not be educational to keep doing that over and over again. So, as I usually do in Absolving, but if you don't know how to do stuff during a contest, then you should also, outside of contest, practice what happens if you don't know a counter test. Okay, we will need to stress test or read the solution. This does not help. Expected 1, found 2. Sometimes my solution thinks that some answer is possible, but it isn't. Oh, my solution is still quadratic, right? I have a for loop inside to find the maximum. This is, of course, much easier. It's just a segment tree of maximum. No, this is to do. This is square now. If you put warning in your C++ code and compile, it will give you a warning. But it will compile. You can submit this, but you have a warning. It's a very good method to mark any to-do. I don't know. Do I want to read that? Stress testing is so much, I don't know, robust. Because I know that if I stress test, I will find a counter test. If I just read this through, how do you handle the query A equal to B separately? Let's see. For A equal to B, answer ID is initialized here as the length. And then later in query, when I actually consider every value, what I hope will happen is that nothing interesting will happen if A is equal to B. Because last must be smaller than first. So B minus A is 0. Yeah, like this longest is always 0. Then I claim that last will be smaller than first, so this will not be satisfied. So this is, well, longest is 0. I want to create a test against that. Which I don't really need to do it. I don't really need to do this now. But no, during contest, you don't want to spam submitting submits over and over again because you lose points. Let's say there are just two strings. They are ABC and CDA, so nothing is common. And let's start with one query. The query about range from 1 to 2. This should give me 3. It is 3 indeed. Oh, and I want this in hopefully incorrect version. Okay, that's 3. Now, if I add here another guy, and it has LCP of 4, that might mess up my solution. Yes. Now it looks at this, it considers the common LCP of 4, and it sees that it achieves that in range of 0. And now this fix doesn't allow that. All right, and well, this will not be difficult. I need a tree of maximum, or I can also hope that this quadratic thing will be fast enough. I guess let's use a tree. This part isn't a bottleneck though, because this is just this just will cause n log n, not n square root times log. Let's call this tree big. By the way, because of that base, I can just build once. Big is a segment tree of maximum. Now we have a range query. This is repeating the code a little bit. If I templated the update and query functions, then I could just do it once, but one tree is maximum, the other minimum. I could also multiply all the values by -1 to get the other type of a tree. But it's not complicated anyway. This is a query, range query. What do you not want? Tree. Oh yeah, big. I called it big. I can do an ugly hack. Define tree big and def3. Don't do it at home. This is very bad. But in this range of code, in this, let's say, scope, every word tree is replaced with big. But it's very confusing in general. Don't do it. When there is an update here. Why is it still 2? Oh, I don't like it. I thought that it worked after this, unless I messed up now with a segment tree. Is this correct for the first sample? Yes, it works. Now, did it work before I introduced a new segment tree? Okay, so this didn't work. My if didn't help. Because I do something very stupid here. This should say longest, right? This shows that even if I did this piece of code once, it should be a function. Okay, longest is this, then I maximize longest in a segment tree, just like I did there. I'm over here crying about LeetCode mediums. Well, you'll get there if you spend enough years practicing. Is answer for sure not 4? It's for sure not 4. So what is longest? One. for value 4. I think this should say b minus a minus 1. No, it doesn't make any sense. If b is to the right of, if it's like a is 1, b is 2, then of course this can have value of 1. So there will be one difference between them. If I did this, then would I still have L equal 1? Yes, so it comes from there. I will print the range AB and first and last. This is 0. This is 0. This is 1. So the whole thing should be 0. How is it 1? I thought that I checked this. What's happening? Will using CRR output in some other format than cout? No. But thanks to that I can redirect stuff like this. And now I will only see the standard output. While if you use this, ERR stands for error, and this prints to standard error output. Or something like that. Error output. Whatever. 0. First minus a, that's 0. B minus 1 minus last, that's 0. What's going on? Oh, L is 1 in some previous case when we have those values. Why is 0 not a bad position? Well, it is. First is 0. No, this is a. Why is this not 0? That's an issue. This is okay. For x equal to 0, we do something. And does it matter that L is 1? I don't think so. We multiply it by x. I think I still overwrite answer ID somewhere. Come on, answer 4 is correct. This string has length 4. The answer for this range isn't 0 or 3, it is 4, and it should be, because we just take defa and the length is 4. Oh. So much time wasted debugging. Okay, well, let's modify this test so it would actually catch the mistake, this mistake. The answer here, it says 4, it should be 4, but I claim that if I skip this if, it should be 5. It is 5, so I caught a mistake. Without this if, it was wrong, and it thought that here I actually can achieve LCP equal to 5, just because it occurred here on the right. Great. Now, one hack. Not this. With this simple line, you can remove all CERRs. And second, let's make sure that I use a segment tree. I here removed both parts, that's bad. Would it work for sample test? Oh, it would. So it's not a good information that this is enough in a sample test, and I don't even use this part of range minimum query. So many things can go wrong. We have, by the way, 225 lines of code. Okay. Submit number 2. Machine learning in C++, question mark. Machine learning exists in C++, but not a lot in competitive programming. It passed test 4. So we are moving forward. What contest is this problem from? Codeforces round 435. So it's a very old contest. I think you can use base equal to n and it won't change anything. Mangust, that's not true. Not in my implementation of segment tree. I mean, yeah, I'm aware of versions where they just use double the number of nodes, but then if I need to do anything non-trivial like doing recursion, it will not work for sure. Okay, there is time limit exceeded. I can create a random max test, which will be very bad. You can look at the style of this test. I wonder if I left some place where I still do it in quadratic time complexity. This kind of test is easy to create. But also, if everything here has length 1, then my solution should be very fast. Let's see, maybe I left some for loop. Control F4. This for loop is fine, it's just n square root of n. Same, same, same. But that being said, it's then n square root of n times something. Right. This is bad, unless compiler got rid of it, I'm not sure. I replace this with if 0 then CRR, and I hope that I'm not sure. The question is, if I have an empty for loop over everything in the set, did compiler get rid of the full for loop? That's a nasty mistake. If I again get time limit exceeded, then it means that my solution is n squared n times log, just as I thought. So now we know that this was an issue and it made my program slow, but we have some unrelated wrong answer. Isn't LCP either 0 or 1? What are you talking about? LCP can be big. Is bad is 0 or 1. First number differ, expected 4, found 1. My answers are completely different than jury's answer, which makes me think that maybe the issue is in a segment tree. Oh, yes, if you're right, Gupta. In this test, if every string is of length 1, then LCP is always 0 or 1. And this set values, it will only contain 0 and 1. I look at test cases sometimes, yes, but you shouldn't if you're a beginner, I would say. I mean, depends. The thing is, I did thousands of problems and I did hundreds of problems during streams, and I don't want to always stress test. It would be boring. But you saw me stress testing many times. Maybe it's now time to read the code once, and maybe I will find a mistake. Get LCP. Maybe from the very top. Why is this here? It should be. This should be global because I am using it there. As long as you have both types of characters, increase the answer by 1, otherwise break, because that's the end of good prefix. This answer is the common prefix. All right. I would get runtime error, I think, even in a sample test if I used wrong bounds, but still, let's be careful. Query of size q, answer of size q, updates of size q, this is of size n. LCP is just n-1 because it's this element versus the next one. For everybody's read, LCP of previous guy, do that. Remember initial LCP. Do the base, create the segment tree, fill with lengths, and then compute maximum segment tree. All right. From this moment until there, when I use tree, I mean big. Okay. Always read the type. If type is 1, then there is query. Change indices to 0 for n-1. Remember the query. Do something in a segment tree. It's maximum of A, B, and everything in between. This, that. Okay. Else there is an update. Position gets from 0 to n-1. Override. Go in. path to the root, always take maximum of 2 children. If you have a left neighbor, okay, updates of this time of this query ID, this guy gets now this value. If you're not the last one, then you have a pair with the next one. Looks legit. For every value, we do something. Start with the initial LCP. For every position, check if it's bad. There is a set of those positions. This should be just n-1 size, but I don't think it matters. This is bad, smaller than the allowed minimum. If it's bad, then insert, cool, compute distances, go from the end, and I said that this should not matter. For everything starting from not n-1 because that doesn't exist, from n-2. Okay, okay. Segment tree of minimum. Populate those n-1 values, and n-1 values of this are enough, I think. From base -1 minimum. Tree update. Override this guy at position I. Handle path to the root. J, J, J. Cool. For every query. This is indeed a query. Find first bed. Find last bed. Out of printing doesn't matter. B minus A. I went through the details of off by 1 mistakes here. That's fine. And off by 1 mistake shouldn't cause the difference of 1 versus 4 in that particular test that we saw. Last minus minus because I don't want that guy. If it's still non-empty, find the maximum. Do I need a max tree or min tree? Max tree, of course. So actually it is the same kind of tree. I should have used functions. This is a max tree. Yeah, Gupta, exactly. AB is interval of strings, but LCP interval is from A to B minus 1. One more test passed. Running on test 60. Let's go. It took me 2 hours and 10 minutes. It's a good practice problem. But now, and 220 lines. Yep, including a few lines of debugging. Itarin ORZ. Was he the one who suggested the histogram? No, that was O'Quinn. Itarin noticed some mistake, right? Okay, I want to check out the solution. Oh, it's very long. I guess it's an old, yeah, 4 years ago. Maybe the quality was a bit worse back then, of editorials too. So it starts here. Oh, it's not that bad. I thought that this part above is also the same problem. Yeah, minimum, histogram, largest rectangle. Try some heights h, that for me that's a value x. See the maximum width we can achieve. Yep, let bu be a value that we'll choose later. So what is bu? Oh, they split into two cases and they solve small versus big separately. This is 300 lines, including some template. This is shorter, but also the lines are much bigger. They needed something. Okay, their solution is not the same. They separately solve a case where this minimum is small, up to 200 or so, and when it's big. I just iterated over cases. And, well, my space complexity is linear. That's nice too. Segmentary number I has 1 at index this if LCP is at least that. Okay. So they have a segment tree built on binary sequence of zeros and ones, and then you can, in a node of a segment tree, you can keep such a value that it will tell you how many ones there are at most in this subinterval, how big prefix and suffix, I guess. We can merge those. What they do in the other case. They only iterate over those heights that appear. Loop over the big columns. Oh, they use the fact that if the minimum is big, then the range must be very short, or the number of columns with big height is small. So they can iterate over all the positions where the height is big. Yeah, that simplifies this case, but I think in my solution it's cool that I solved both cases at once. I think I have the shortest solution if we compare with those two. We can measure the number of characters, but also later I will see what people did during a contest. Let's call it 1 CPP. Hmm. 6,700 characters. Maybe also this makes sense. That many lines, tokens, and characters. (4,100 characters). So I have more characters, so this one is shorter in terms of characters, but I think it's just ugly. It uses short notations and very long lines. No debugs. Yeah. My solution is not worse than this one. Okay, I know everything I wanted to know from the editorial. Is this based on KMP? No, not even similar. Last one about min and max, you skipped it while reading the code. You mean here in my mistake I found about min and max? I didn't skip. You skipped it while reading the code. Maybe I read the code twice, I'm not sure. Cool. 2 hours passed. Oh, and I did all of that because in Discord the bot suggested this problem. Let's see. How do I actually use it? Do I need to type something? Let's see, I started at 18. There's a lot of stuff here. Maybe we should have a separate channel just for Git-Good. There should be a command like got-good or something like that. Got-good, okay. I gained 8 points, and now is there a leaderboard? Maybe this. How do I get the leaderboard for this division? Monthly Git-Gooders. And division? I guess minus div1 or something like that. It didn't work, just div1. Okay, well, division 1 is just for people above rating of 2100, so it will be easy to be close to the top. Then it's cool. If not many people here, not many strong people here will do the challenges. I will try to get top 1. Every time when you grab a problem, it will give you a problem on your level, and then if you solve it, you get 8 points. You can also grab a harder problem or something slightly easier, but then you get respectively more or fewer points. Colin not here. Maybe he just didn't do the problem. 4th of May. So yeah, it's monthly, so for sure in a week or two we will get more stuff here. Yeah, nice practice. I like the problem. It was on proper difficulty. Maybe I'm not happy about the amount of time I spent. Still, it's fine. It was fine for a stream. Nothing very complicated. I wonder how much time I would spend if it wasn't during a stream and I just focused. But also sometimes the chat helped me. Standings not here. Back then 3 people solved it and it took them, this is strange. Oh, this is a team, so never mind. 48 minutes and 1 hour 8 minutes. I think I would get above 1 hour. I should have created functions for a tree. Maybe I should just always have them. There is, I think this is copy-pasted seg tree. Oh, this is ugly. Something with merging. All right. What's up, chat? Does this chat use Codeforces handle? In Discord, you need to link indeed your Codeforces handle. The problems are on your level, yes. So this one was on my level. Join Discord, everybody. Thanks to Dangel for developing this bot. And if you want to use it too, join the server, go to bot commands and try it yourself. It will give you a random problem on your level, and then there is some monthly leaderboard of this solving non-trivial problems. Okay, thank you all for watching, and if nobody's streaming, then I'm not trading. Yep, bye bye.